Okay, so in this video, I will be going over key equations that we'll be using, and then I'll go ahead and jump into the projectile motion questions, okay? So key equations that I wanted to go over. It's going to be basically the same equations that we used last time. So we have our x of f equals x of I plus v of I t plus 1/2 at squared. Final position equals initial position plus initial velocity times time plus 1/2 acceleration times time squared. And then we also have our v final plus v initial plus at. Okay? So in the question that you asked me about, so Bob is throwing a ball from a cliff. We're going to name the cliff height h. And the ball goes something like this. And it lands, I think it was 121 meters away from the base of the cliff. It also gives us that right here it takes 0.710 seconds to get to this point. It also gives us initial velocity of 34.1 meters per second. Okay? So, using this information, we're actually going to break down the problem and not do it as one whole, function. We're going to split it up like this. So we're going to pretend like this doesn't even exist, and we're just worrying from here to here. Okay? So, what we are going to write down are our knowns. Knowns. So what do you know about your y's? Okay, so your y of f. We are actually not going to use this point as our y of f. We're actually going to use this point as our y of f. And why this is extremely useful is because right here we don't know what our velocity is. Okay, here we know what our velocity is, but here we don't really know. At the top, we know that our velocity in the y direction is going to be 0. And that's because at a very small moment in time, when the object is changing its direction, it stops. Stops for a very small decimal point in time. It's actually stopping. So we know at the top it's 0 meters per second. So, okay, they didn't give us the time for this, but we're splitting this problem here into half. So time will just be 0.710 divided by 2, which is going to be 0.355 seconds. So our y final, we don't really know what that is. We don't really care at this point. Y of I is going to be at our h plus 2 height, this, the cliff, 2, because that's where he throws it from. Our v initial in the y direction. This is also another thing. They give you velocity, but they give you velocity in terms of x and y combined, so you actually have to break them down to x and y components. So it'll be 34.1 sine of theta. We don't know what theta is. Theta is our angle. And we're going to figure that out right now. Our Vf of y is equal to 0 meters per second, according to this. And then our acceleration in the y direction, negative 9.8 meters per second squared. So in order to figure out, the first thing we're going to do is we're going to try and figure out what theta is. So we're going to go ahead and use the second equation. So Vf equals Vi plus At. Vf equals 0. Vi equals this. We're just going to leave it as Vi for now. And then acceleration, negative 9.8. Time is 0.355. So negative Vi equals negative. And if I plug this into my calculator, it'll be negative 3.48 seconds. Or meters per second. And since these are both negative, we can just go ahead and get rid of those. So 3.4 meters per second. So that's our V of I. Now, we're going to go ahead and try and find theta. So what we're going to do is actually substitute this. Let's do 34.1 sine of theta equals, and then our negative 9.8. This is going to be negative actually. So I'm basically just rewriting this. These two are the exact same thing, but now I'm just, instead of writing VI, I'm literally writing down this value here. Okay, so I'm going to divide this side by 34.1, right? And since now that they're both negative, it's positive now. So in order to get the angle that we need, which is theta, we're going to multiply both sides by the arc sine. So this is going to go away, so this is just going to be left with theta. So we're going to plug this into our calculator. Oops. The arc sine of 9.8 times 0.355 divided by 34.1. Okay, my theta is equal to, I'm going to write it over here, 5.86 degrees, okay? So this is what we're going to be using from here on out, so this doesn't really matter. Okay, so I'll write down my theta right here, 5.86 degrees. Awesome. So now, which equals 3.48. So now what I'm going to be doing is using that to find my x components. So how far along? Okay. I'll go ahead and write my x components right here. So my x of f equals, okay. Before we jump into that, let's find our VI of x. Because I'm actually going to be using the entire equation now to find these. So I'm just going to go ahead and just do my initial x velocity. So x of I, VI of x, VF of x, and acceleration of x, which we know is 0 meters per second. Always 0 meters per second squared. Okay, so VI of x, very similar to this one, but instead we're using cosine. And we know our theta now. Our theta is 5.86. So let's go ahead and put that into our calculators. 34.1 cosine of 5.86. You have 33.92 meters per second. Awesome. So now we're going to use the entire equation from here to here. We're going to use this equation right here, so we can find time from here to here. Before we had time from here to here, here to here. Now we're trying to find time from here to here. And we can do that now because we know our initial velocity in the x direction, and we didn't know that. We had to do that by finding the theta in the y, because that's where we had the most information. Okay, so I'm going to go ahead and use this equation. This in blue. So x of f equals x of I is VI of t plus 1/2 AT squared. We already know this is 0, so x of f is 121. X of I, the base of the cliff, is 0, plus our initial velocity, 33.92 t. So I'm going to divide this by 33.92, divide this by 33.92. And we'll go ahead and solve for time. So 121 divided by 33.92. So total time is 3.56. So it'll take the ball 3.56 seconds to get from here to here. And now that we have time, 3.56. same. Same, same, same. And now we're going to use the same equation, but now we're going to use it in the y direction so we can figure out the height. So we're going to use y of f equals y of I plus bi of t plus 1/2 at squared. Y of f, y final is the ground, so that's going to be 0. Y of I is up here. So I'm going to label that h plus 2. This is h plus 2 of the meters where he threw it. Plus initial velocity is 3.48 times time, which we said was 3.56, plus, I'm going to write this down here because I'm running out of space, 1/2 negative 9.8 times 3.56 squared. Okay, so I have to plug these numbers in. Let's move this over to this side. It's going to be negative h plus 2 equals, and let's go ahead and make these calculations, 3.48 times 3.56. Okay, so that is going to be 12.39 plus, then we're going to do 4.9 times 3.56 squared, which will be minus 62.1. And I say minus because this is negative. So add those together. We'll get negative 49.7. 49 to negative 49.7. So it's going to be negative h minus 2. So I'm going to go ahead and bring this 2 over to this side. So add that plus 2, which is negative h equals negative 47.7. And those are both negative. So h, the cliff, will be 47.7 meters. But from where he throws it up here, then it'll be 49.7 meters. Okay? So, if I got any of my calculations wrong, go ahead and let me know. If anything confused you, go ahead and we can discuss it. So I hope this makes sense.